Tesla is once again at the forefront of an industrial transformation that promises to redefine the standards of automotive manufacturing. This time, the spotlight is on the revolutionary 50,000-ton Giga Press, the largest high-pressure die-casting press ever built in the world. This gigantic machine has the impressive ability to produce 5 vehicle chassis simultaneously in just 5 seconds. This is an unprecedented feat in the history of the automotive industry. Innovation lies not only in size, but in efficiency and automation of the process. Tesla has managed to integrate artificial intelligence, robotics, and materials engineering to create a highly optimized system. The process begins with the casting of aluminum, which is melted at extremely high temperatures before being injected under colossal pressure into molds designed with extreme precision. This approach allows you to create single, massive parts by replacing dozens or even hundreds of smaller components. The result is a chassis that is lighter, stiffer, and has fewer points of failure. Tesla has already used the Giga Press in previous versions. The first operated with 6,000 tons and was used in models such as the Model Y. Later came the 9,000-ton version, dedicated to the Cybertruck. Now, with the arrival of the 50,000-ton machine, the company is ready for a new technological leap. This new press will be a key part of the production of the Cybercab, the brand's next high-volume vehicle. In addition to the direct impact on production, the use of this new technology represents a significant advance in the way Tesla approaches the manufacture of electric cars. The Giga Press enables unprecedented integration between design, engineering, and automation. With fewer parts to assemble, the time to manufacture a car is drastically reduced. While a traditional vehicle can take dozens of hours to assemble, Tesla reduces that time to just a few minutes, or even seconds at specific steps, such as molding the chassis. Structural simplification not only affects assembly speed, it also reduces costs, increases structural strength, and improves vehicle safety. Casting a single piece of the rear or front of the car means fewer welding points, fewer screws, and less variability in the production process. The use of cast aluminum also contributes to the lightness of vehicles, positively impacting battery range, performance, and energy savings. With strict temperature and pressure control, the Giga Press operates with surgical precision, avoiding failures such as air bubbles or uneven solidification. To achieve this level of quality, Tesla developed advanced cooling systems capable of maintaining thermal stability throughout the process. Additionally, inert gases are used to prevent oxidation, ensuring clean and efficient casting, even in large volumes. Molds need to be able to withstand immense pressures. Therefore, the engineering involved in creating these molds is a field in itself, with cutting-edge technology. Process automation isn't limited to casting. Smart sensors monitor every step, feeding AI algorithms that make decisions in real time. This ensures that the process runs smoothly, and in the event of any anomaly, the systems are able to automatically correct it or alert technicians. One of the biggest highlights is the environmental impact. Tesla is able to recycle excess aluminum, reintegrating it into the production cycle with minimal waste. This contributes to a reduced carbon footprint and is in line with the company's sustainable proposal, which seeks a cleaner production chain. Large-scale casting also allows for greater standardization and less variability between units produced, raising the quality standard of the fleet. In the case of the Cybercab, the use of the Giga Press will allow for an architecture with around 80 structural parts, compared to 200 in the Model Y, a reduction of 60%. This not only speeds up the assembly process, but also simplifies the logistics of parts and supplies, making production much more efficient. Modular construction, based on large single components, also facilitates future vehicle repairs and upgrades. With ambitious plans to produce up to 7 million Cybercabs per year, Tesla is gearing up for a level of scale similar to that of the electronics industry. It's as if car manufacturing were approaching the smartphone assembly lines, fast, standardized, and ultra-technological. This approach breaks with the tradition of the automotive industry, which has historically relied on hundreds of suppliers and manual processes. The factory of the future that Tesla is designing requires fewer people on the assembly line and more engineers monitoring algorithms and robots. And this is where the integration of AI and manufacturing becomes so powerful. Real-time analytics ensure uninterrupted efficiency and quality. This drastically reduces the margin of error and increases the consistency of the final product. something that few competitors have managed to achieve. With each new Giga Press, Tesla extends its competitive advantage, reducing costs and increasing its ability to meet global demand. The Model 2, Tesla's future affordable car, will also benefit from this technology, enabling a competitive price without sacrificing quality. Mass production of this model will only be possible thanks to advanced automation and structural simplification made possible by large-scale casting. With fewer parts, less labor required and more process control, the cost per unit drops considerably. Additionally, the time between ordering and delivery of a vehicle can be drastically reduced, which improves the consumer experience. The factory thus becomes more predictable, scalable, and resilient, fundamental characteristics in times of unstable logistics chains. The foundations required to install the 50,000-ton press are as large as those for a 2- or 3-story building. This shows not only the scale of the operation but also Tesla's commitment to investing heavily in cutting-edge infrastructure. By taking risks and developing technologies that other automakers don't even attempt to explore, Tesla is positioning itself at the forefront of the industry. The Giga Press is more than a machine. It represents a new production model where speed, sustainability, and automation go hand in hand. With this level of innovation, Tesla is not just making cars. It is rewriting the rules of how the automotive industry can operate in the 21st century. The impact of Giga Press goes beyond numbers and engineering. It symbolizes a new era of industrialization in which customization and scale are no longer mutually exclusive. By fusing large parts of the vehicle into a single piece, Tesla eliminates the need for complex processes such as welding, riveting, and gluing in multiple stages. This radical simplification represents a paradigm shift, where vehicles can be designed with more freedom, without the limitations imposed by traditional assembly. Structural design is now guided not by assembly, but by casting efficiency. This opens the way for shapes and geometries that would previously have been unfeasible or uneconomical. Furthermore, the very concept of the production line changes. Instead of multiple sectors responsible for different parts of the chassis, everything starts with a single, monumental foundry. This centralization in production reduces errors, improves quality control, and allows for leaner management of resources and personnel. With robots operating in sync, sensors monitoring everything in real time, and algorithms predicting failures before they happen, the factory becomes almost self-sufficient. The use of artificial intelligence goes far beyond Giga Press control. It encompasses everything from demand forecasting to scheduling predictive machine maintenance. This allows Tesla to maximize press availability, reducing downtime and increasing production volume. Another point worth highlighting is the impact this innovation has on supply chains. Reducing the number of parts means fewer suppliers, less logistics, and less risk. Every part removed from the process represents one less supplier, one less delivery, one less potential failure. Efficiency cascades down the drain. Not only does Tesla save on transportation and storage, it also reduces its vulnerability to external disruptions. In an increasingly volatile world with supply chains frequently shaken by crises, this level of autonomy is a decisive strategic advantage. The ability to produce key vehicle parts in-house gives Tesla almost complete control over its own operation. This includes standardizing processes across different gigafactories, which can reproduce the same model with minimal variations and consistent results. Tesla factories are not just assembly sites, but real-time innovation hubs where data and production go hand in hand. This data feeds algorithms that learn from each casting cycle, automatically adjusting parameters to maximize quality. This continuous evolution makes Tesla one of the fastest companies to optimize its own production systems, something that traditional competitors still struggle to achieve. And it's not just about speed or volume. Standardization brings direct benefits to the end consumer, who receives a vehicle with less variability in finish and greater structural consistency. Less variability means fewer recalls, fewer defects, and more reliability, factors that directly impact the perception of brand quality. The consumer may never see the Giga Press in action, but they will feel its effects in every detail of the car, in the silence while driving, in the stability on curves, in the confidence behind the wheel. This approach also makes maintenance easier, as unified structures have fewer points of wear and tear and need for repair. Safety is another benefit. Unique, Fused structures increase resistance in collisions, distributing impacts better and protecting occupants. For Tesla, every technical breakthrough is also a strategic move. The company knows that its foundry technology is difficult for competitors to replicate quickly. Even if other automakers decide to invest in giant presses, it will take years for them to reach the same level of integration and automation that Tesla has already mastered. Meanwhile, Elon Musk's company continues to gain an advantage, not just as an automaker, but as a benchmark in advanced manufacturing. This domain of automated casting could, in the future, be licensed to third parties, or even become a new business arm for Tesla, providing industrial solutions. With this, Tesla could generate revenue not only from vehicles, but from technology and production know-how, further expanding its presence in the sector. The Cybercab, which will be the first model to fully utilize the 50,000-ton press, represents a milestone in this new approach. With a design conceived from the outset to be fused into large modules, the Cybercab symbolizes the union between aesthetics, functionality, and industrial efficiency. The model aims to be extremely affordable, reliable, and easy to mass produce. Everything the market is looking for in an urban vehicle of the future. By drastically reducing the number of parts and assembly steps, Tesla is able to offer a cheaper car without compromising profit margins. This balance between cost, quality, and scalability is something that few automakers have managed to achieve to date. If it can deliver the Cybercab as promised, Tesla will not only be launching a new car, it will be setting a new standard for automotive production. This standard could force the entire industry to rethink the way it produces, from car design to factory layout. The speed at which Tesla develops and implements these innovations is a result of an organizational culture focused on calculated risk and constant disruption. While other companies spend years planning, Tesla is already testing, failing, and improving in short cycles based on real-world data. This is particularly visible in gigafactories, which function as living laboratories of experimentation and continuous adjustment. With this rate of iteration, the company can launch better products, faster, and at lower costs. The dream of any industry. Decentralized yet standardized production allows factories in different countries to quickly adopt advances made in any other facility. With each innovation cycle, Tesla reinforces its position as the only automaker that truly dominates all phases of the electric vehicle value chain. From software to hardware, from raw material extraction to casting and final assembly, everything is managed in an integrated manner. This vertical dominance is what allows Tesla to innovate so quickly and implement technologies like Giga Press before any competitor. In the long run, this creates an almost insurmountable barrier to entry for new companies or for traditional automakers trying to adapt. Industry history shows that major technological shifts often redefine who leads and who fades, and Giga Press could be just that game changer. By transforming casting into an automated art, Tesla is not only challenging the status quo, but molding the future, literally, in high-pressure aluminum.